Your truck just went into a 5 miles per hour derate in the middle of a run. Engine light on, DEF light on, and now you're crawling down the highway, wondering what went wrong and how bad this is going to cost you. Today, I'm going to break down exactly what causes diesel trucks to derate, what's actually happening in that system, and what you, or your mechanic, should be looking at first. Let's get into it. First, let's talk about what a derate actually is. A derate is when the ECM, that's the engine control module, your truck's brain, intentionally limits power or speed. It's not a malfunction in the traditional sense. It's the system working exactly as designed. The ECM is putting itself in protection mode, either to protect expensive components from further damage, or in some cases, to enforce emissions compliance. There are two main types. A torque derate limits how much power the engine can make. A speed derate caps how fast the truck will go. And yes, that can go all the way down to 5 miles per hour. You've probably seen that one. Then there's something called an inducement, which is specifically tied to the emission system and operates on its own escalating ladder. We'll get into that in a minute. The important thing to understand is this. A derate is a symptom, not a root cause. Something told the ECM to pull power. Your job, or your mechanic's job, is to find out what. Most derates on trucks built after 2010 trace back to one system, the aftertreatment system. And the piece of that system that causes the most headaches is the DEF system, diesel exhaust fluid. DEF is a precisely blended solution, 32.5% urea, 67.5% deionized water. That ratio isn't arbitrary. It's mandated. The purity matters too, which is why you can't just use any fluid off a random shelf. Here's what DEF actually does. It gets injected into the exhaust stream through a dosing injector, upstream of what's called the SCR catalyst, selective catalytic reduction. When DEF hits hot exhaust gases, a chemical reaction converts the urea into ammonia. That ammonia then reacts with nitrogen oxides, NOx, in the exhaust stream inside the SCR catalyst. The output is nitrogen gas and water vapor, completely harmless. That's how modern diesel engines meet EPA emission standards without sacrificing power. The ECM is monitoring this entire process constantly. DEF level, DEF quality, DEF temperature, dosing rate, SCR catalyst efficiency, and NOx sensor readings, both upstream and downstream of the catalyst. If anything drifts out of spec, it starts logging fault codes. Enough of the wrong codes, and you're in derate. Now let's talk about the inducement system, because this is what actually causes the hard derates, especially that 5 miles per hour wall. The EPA required truck manufacturers to build in what's called an inducement system on all trucks after 2010. The idea is simple. You can't just ignore your emission system. The truck won't let you. Here's how the ladder works. When your DEF level gets low, you get a warning light. Ignore it, and as the level drops further, you hit a first-level inducement, typically a 25% reduction in available torque. You'll notice that. Keep ignoring it, and eventually, the truck limits you to 5 miles per hour. On some platforms, it won't even restart after you shut it down. But low DEF level is just one trigger for inducement. You can also get there from a confirmed SCR efficiency fault, meaning the system tested NOx conversion and the numbers didn't pass, or from a DEF quality fault, which happens when the DEF concentration is off. Either someone put bad fluid in, or the DEF degraded from sitting too long in extreme heat, or in some cases, tampering detection. If the ECM suspects the after-treatment system has been modified or deleted. Each manufacturer implements this a little differently, but the underlying logic is the same across Cummins, Detroit, Packer, Mack, and Volvo. Let me walk through the fault codes you'll most commonly see when a truck is heading into derate territory. SPN 3031 DEF tank level sensor. Low DEF level is the obvious one, but a failed sensor will trigger this even with a full tank. Don't assume it's actually empty until you verify physically. SPN 3364 SCR operator inducement severity. This one tells you where you are on the inducement ladder. It's basically the ECM saying, here's how serious this has gotten. SPN 3251 DPF differential pressure sensor. A clogged DPF means region can't complete, and that failure cascades into the SCR system over time. This one gets overlooked. SPN 4094 reductant dosing unit performance. This points at the DEF injector, the DEF pump, or the lines between them. Crystallization and clogs are very common here. SPN 2978 NOx sensor performance. If your upstream and downstream NOx readings don't match what the ECM expects, it'll flag an SCR efficiency fault. Failed NOx sensors are extremely common on higher mileage trucks, and they're not cheap. None of these codes alone tells you the whole story. You need to look at the full picture, active faults, inactive faults, and freeze frame data to trace it back to the actual root cause. All right, so you've got a truck in Derate. Here's a logical diagnostic order. Step 1, pull codes. Don't guess. Get a scan tool on it, JPRO, Insight, Diagnostic Link, Davi, whatever fits the platform, and pull everything, active and inactive. Look at freeze frame data if available. Inactive codes tell you what was happening before the problem became obvious. Step 2, DEF level and quality. Top it off if it's low, but also check quality. If you suspect bad DEF, maybe it came from an unfamiliar source or sat in a hot tank for a long time, drain it and refill fresh. DEF has about a 2-year shelf life under normal conditions. Heat shortens that significantly. Step 3, NOx sensor data. With your scan tool live, compare upstream and downstream NOx values at normal operating temperature. If downstream is reading close to upstream, the SCR isn't converting. That's either a failing catalyst or a dosing problem. Step 4, DEF dosing system. Look for crystallization around the dosing injector and lines. That white crusty buildup is DEF that didn't fully atomize. A clogged injector is one of the most common causes of SCR efficiency faults, and it's often overlooked because it's not always obvious without pulling the injector. Step 5, DPF condition. If the DPF hasn't been cleaned in a long time, a partially plugged filter will prevent regen from completing, which creates a chain reaction back through the whole aftertreatment system. If you're seeing DPF differential pressure codes alongside your SCR codes, start there. Work the system from the data. Don't replace parts until you've got a direction. That's the full breakdown on diesel Derates and the DEF system. It sounds complicated, but it follows a logical path once you understand what the system is actually trying to do. The ECM isn't your enemy. It's reacting to data. Give it accurate data, and it'll leave you alone. If you've got a specific fault code you're dealing with, drop it in the comments. I may just make a dedicated video on it. Hit subscribe if you want more breakdowns like this. We go deep on diesel diagnostics every week. No fluff. I'm Big Brain Diesel. Catch you in the next one.